So hello guys, in this video I want to start a new video series called The Essence of Computer Programming. So in this tutorial what I want to do is I want to share my approach, my understanding about computer programming, and I hope that this understanding makes it easier for beginners and for even advanced levels when trying to tackle what is computer programming and what is the mindset that people have to have in order to program something at a pretty easier pace and a more effective one. So what is computer programming? What is the approach? What is my approach that I take while trying to comprehend computer programming? So I see computer programming as this. Computer programming is like cooking. Let's say you want to create, or let's say you want to cook an omelet, and you have this omelet in your head. You picture the omelet, and it's this really tasty omelet with some green sparkles, yellow skin, and some mushrooms with some cheese topping over it. You have some tomatoes at like the topmost layer. So I'm just going to draw that just to make sure that we're on the same page. I'm horrible at drawing though, just a disclaimer. The white one is a plate. Sorry. And there's some green, I don't know, like this type of, what do I call it? Like the spices and these little tasty stuff. You got these tomato toppings at the top. I don't know, you got some cheese. I'd say white is cheese, okay? White is cheese. Or maybe yellow is cheese. Yeah, there we go. Yellow is quite cheese. So in cooking, in order to make the omelet, the first thing that you have to do is to identify the key ingredients that you need in order to cook that omelet. So let's say the key ingredients I have is an egg or eggs, tomatoes, spices, so salt, spices. I'm just going to group them into one. The sparkly series, right? The sparkly guys. Cheese, Parmesan cheese, lovely. And mushrooms. My mom, she cooks the most tastiest omelets and she puts mushrooms. What else? Milk. Yes, my mom puts milk. She cooks the most tastiest omelets. So that's a tip for you to cook the most tastiest omelets. Okay, so the key point is this. You have some ingredients that you have identified. The way you cook your final objective, your final omelet, is to only utilize these ingredients using specific functions. Let's say eggs, I crack them, and then I pour the milk, right? So crack, pour, whisk. I don't know how to spell whisk. Whisk, tomato, cut, salt, sparkle, sprinkle, but I'll say sparkle. Cheese is grind. Mushrooms are wash. So these are basically specific functions in cooking. In order to extend this type of analogy into what you have to know in computer programming is this. Once you know the objective, try to identify the ingredients that you need in order to fulfill that objective. And those ingredients in computer programming will be your knowledge about computer programming. The eggs become, let's say, addition and subtraction, arithmetic. Milk becomes, let's say, an algorithm. Tomatoes can become functions of something. And those are types of the knowledge that you know, the syntaxes and the grammar rules of a computer programming language. And the most important part is you only use these types of knowledge that you know in order to create your objective. If you don't know a certain knowledge, don't try to fit your way in while trying to make something. What you don't know is what you don't know. So identify the key holes, the key gaps that you have while trying to fulfill that objective. So when you're programming something, make sure that you think of a hypothetical knowledge, hypothetical concept that you might imagine that hypothetical concept. If it's there, then you can fulfill that objective. So the cooking of the omelet analogy is very straightforward. If you don't have eggs, you can immediately imagine the eggs being that hypothetical concept you need in order to make the omelet. But in order to extend that analogy, omelets can become thoughts or ideas or the final product of a program. Then your eggs, your ingredients, will be a hypothetical algorithm. So try to always practice identifying or creating your own hypothetical concept and search it on the internet. And these specific functions right here, the whisk, the wash, the cut, these are basically what? You can make them as formulas, right? The wash never change. Wash is what? You wash something with water, right? You rub your ingredients on water, right? Wash never changes. Therefore, you can create it as a formula or a function. Cuts, you cut something into tiny slices. Does cut ever change in cooking? No. Cut is always cutting something with a knife into small pieces, right? It's a function. Whisk is also a function. Grinding is also a function, right? So these formulas are what you say as trying to abstractify your process. So you wash something multiple times, right? You have a pattern of washing. So you can actually abstractify your pattern of action so that you create a specific function that you can define and use. Grinding is the same thing, right? You have a specific action pattern. You always do something that shreds an ingredient into small pieces. So that pattern can be abstractified into a definable function, which you can name it as something called grind, right? So this is a powerful tool when you're trying to program something. You want to basically qualify the certain actions that your program needs to execute, and the ingredients are what you call as what? Programming knowledge, programming grammar, the syntax, anything like that, anything like it, right? Grammar, syntax, you name it. Keywords is also important. And knowledge that you have can be even algorithms. So this whole process is what we call as computational thinking. So if you know computational thinking, computer programming, I think, will be much more easier, because I've seen, myself included, that in order to create an objective, in order to fulfill an objective, let's say I want to create a calculator, I struggled because this frame of mindset was not established when I was programming it. These set of instructions will always have errors, will always have logical gaps, because I did not identify first my knowledges that I needed to know in order to create the calculator, the specific functions I needed to put in order for the calculator to operate. And just by identifying those, I could just, match them out. I could just match them out in a certain flowchart or some type of algorithm. Then I could have secured my logical gaps. I could have filled all my logical gaps. I wouldn't have any errors because my logic is coherent in order to make the calculator. I hope this helps a little bit in computational thinking. And in the next video, what I want to introduce are the 5 main ingredients that you have to know in computer programming. And I believe that with only those 5 ingredients, you can basically code about 80% to 90% of all, programming challenge or problem that you encounter in your computer programming career. The rest of the 20 to 30% is the advanced knowledge. Those are like the most advanced stuff that you do when you're basically doing enterprise coding or graphic user interfaces and so on and so forth. So right now I'm going to explain computational thinking in a more technical way. You have an objective. Label the basic elements that you need to fulfill this objective. You only use these elements in order to create the objective. Do not somehow invent a hypothetical evidence in order to create this type of objective. This seems obvious, but it is always easy to catch. You will not notice of you creating this type of imaginary evidence. Third, as you're brainstorming your functions, you might encounter multiple simultaneous patterns of actions that you have while trying to fulfill that objective. Make sure that you create a definable function for that. Now, this is called abstractification. So once you keep on building your evidences, your actual knowledges into more and more abstract concepts by combining each of these smaller to bigger concepts, you will eventually arrive to what you will know as an objective. So this whole process is called computational thinking. More specifically, this is called the bottom-up approach in development. Another element that you can take a look at is the top-down approach. The top-down approach is just in reverse order. Now, the top-down means you have an objective, you divide the objective into the next smaller piece of that objective, and then you keep on dividing until you get something that you recognize as knowledge. So what top-down requires you to do is to identify hypothetical concepts, hypothetical milestones, hypothetical knowledge, or hypothetical concepts that you might invent and logically connect that to the objective. Okay? And the last bit that you'll see is not the hypothetical concept, but actual knowledge that you know. So immediately, if you backtrack in a top-down approach, you would immediately see the necessary pathways that you'll take in order to fulfill your objective or in order to develop the thing that you want. So I hope this tutorial helped you. Please give me feedback, whether if it was good or bad, if it was helpful, if it was not. Please let me improve. And I'll see you next time.